Okay, I think we are live. Hello, everyone.
Hello, racers.
Hello, racers. How are you doing today?
We have a beautiful weather here in Wrocław. We are the very first employees of the brand new branch of DeepRacer.lab in Poland. Simon?
Yes, I'm Simon. I work as a DevOps engineer in DeepRacer.lab Poland, and here is Piotr.
Peter, I'm business developer responsible for the EMEA region. Welcome you on this very particular session because we'll be not very technically oriented.
Yes.
We will be speaking today a little bit more fun about racing, about artificial intelligence.
Yes.
And the AWS platform.
Basically, our goal is to show you a way how can you relax after your work with still learning something fun, which is actually machine learning, artificial intelligence. But don't be scared about those words because it's very simple. Everything will explain everything step by step. The only thing you need to have is a laptop with internet connection, AWS account, and maybe basic knowledge about Python programming, Python syntax. But anyway, the Python is not that important.
Basically, we have two goals for this session. First of all, is just to introduce you to machine learning and that you see how AWS is doing that,
helping you with start.
Exactly, to start to introduce you. The second is just to encourage you to be a racer and to start with your own brand new car run by reinforced learning by those algorithms. And Simon will be explaining you how it all works. I will be just helping a little bit and making some comments related to business because machine learning is all over.
Right so to avoid confusions, I will speak strictly about the AWS DeepRacer service, and Piotr will speak about the business in machine learning, about machine learning in business maybe. Yes? Okay. So first of all, AWS DeepRacer, it's a virtual league of autonomous cars, remote control cars, but they are not really remote controls. They are controlled by artificial intelligence. And before we start the session, we would like to encourage you to check out the AWS introduction video prepared by Amazon, so you will know what we are talking about.
Hello everyone, I'm Ryan Marine. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning. Developers will compete for the fastest lap of the day. Hope to see you at reInvent 2019.
So guys, are you already tuned? So cheers for the new DeepRacer.lab branch, and let's stick a little bit to the theory of machine learning.
But before we start talking about machine learning, I said that the only thing we need is a laptop, internet connection, AWS account. And what we saw in the video were actually the real devices, real cars. Piotr, do we need that car?
No, we don't need that car. I know it already. That what we will be playing here is fully virtual. So your laptop really is fully enough. So we are fully equipped just right now.
Yes, all our models will run inside a simulator prepared by AWS. Everything is prepared and you don't have to worry about any complex stuff, really, believe me.
Just follow what Simon has to say today and you will be capable and fully equipped to run and configure your own AI run racing car.
And what's more important, you will be able to join our virtual race and win prizes. Remember, we have prepared a virtual race for you and you will have 7 days to train your own model and submit it to the race. The fastest free models, the owners of fastest free models will receive a prize from us. which is $200 credits for AWS platform to spend. So
exactly, because it's not only Soaring Lab Race, Amazon is participating
yes.
in that, not only giving us the possibility to use the platform, but also giving us valuable prizes as well.
Yeah, so remember, my goal at the end of this presentation is to invite you to the DeepRacer race and to show you how you can submit your model and win the $200. It's not small amount. Okay, back to the topic. Okay. What is machine learning?
Okay, so the machine learning is the algorithmic application of AI that gives systems the ability to learn and improve without ample human input, with very little human input. There's a similar concept of data mining or predictive modeling. So the goal is to predict the outcomes without software being explicitly programmed. The idea is that an algorithm is used to get data from the world and to go back to the model so that it improves over time. You probably know that already from the recommendation engines, from search pattern prediction, spam filtering, or any other systems detecting fraud, etc. And there are three different types of machine learning: supervised, unsupervised, and the king of machine learning.
Actually, reinforcement learning is part of unsupervised learning. And the difference is, just give me a second, I'll explain it. Okay, supervised learning means we supply our models with input data and expected output. So our model is training based on that labeled data.
Yeah,
so when
humans they need to have need to give the feedback to the accuracy of the end results.
And unsupervised learning and reinforcement learning is another scenario, because we don't provide any labeled data, we don't provide the input and outputs. We just put our model inside the environment. And
the model is reviewing the massive banks of data and arrive at conclusion based on previous examples and exercises that it's doing.
Exploring the environment, what is important, the difference. The model is exploring environment by itself and is learning based on its experience. And how it's done? Let's speak about DeepRacer model, because this is our goal and I think it will be easier. We put our car on a track and the car starts to drive, and we provide to our car something called the reward. We will be writing reward function, but we'll go back to it in a few seconds. So how the teaching is done? When the model takes desired action, the action which we want it to do, we provide the model with the reward. When the model, for instance, is crashing or it's driving off of the track, we don't provide the reward. And the only motivation model has, our car has, is to receive the highest possible reward. So the model, it's like a dog and teaching the tricks. You give him a snack.
Good doggy, bad doggy.
Yeah, good doggy and bad doggy. So after some time, the dog will behave just to get the snack again. And the same applies to DeepRacer. The DeepRacer will repeat the actions with higher reward.
You will see that later on, and I can just tell you that it enters already the automotive market. What draws my attention last month, it was a scientific paper on automated vehicle symposium in California, and it proved that reinforced learning had the best score in fuel-saving research for autonomous driving. So rule-based and optimization-based models proved as less effective, and reinforced learning augmented the fuel saving up to 30%, which is pretty much.
Yeah, so just now we'll jump back to AWS console. Here I am, and I will show you step by step how you can create your first DeepRacer model. Go to your AWS console, search for DeepRacer, and here you are. On the left side, you have many. I strongly recommend you to start with Get Started, because here you have beautiful page prepared by Amazon, the Start Learning Reinforced Learning. It will show you step by step, explain you all the details. I won't explain it during this session because we don't have enough time. And after that, I think you will be fully prepared to create good model. But I will jump now to creating a model, actually. So you have first to supply it with some name. Let's name it Sorin DeepRacer.2, because I have already one. So I have to create model number 2. The description field is optional. You don't have to provide it, but it's good practice to correctly describe your models, because you will avoid confusions after a few weeks of playing with DeepRacer. The next thing to select is environment. An environment simply means on which track we want our model to train. I will take the reinvent, so reinvent 2018, because it's pretty simple and pretty wide. We have then the race type. We have time trial, object avoidance, and head-to-head. Object avoidance means on the track we'll have some boxes, which are the obstacles. Our car has to avoid them. Head-to-head means we'll have another car on the track also, so we have to avoid another track. Those are very advanced type of racings. For beginners, I recommend the time trial because it's the simplest, and this is exactly the type of our community race, and it means the fastest lap is taken into account, and we are just considering the lap time.
Okay, so we are alone on very wide track,
yes.
And the community race will
no objects, no other racers, only we and only track. What's next is the agent. Here, it's important that you can select another car, but I will show you how to tune your car later. We'll have covered that section. So I am staying with the default DeepRacer car, and I am clicking next. What's here is the reward function we were talking about. Reward function is like something what is evaluating or checking the decisions made by agent, by car. So at each step, which means let's say each centimeter of the track, that's not true, but just to avoid difficult definitions, each centimeter of the track, we are executing this simple Python code just to get the feedback to car if it made good decisions or not. So we are giving high reward or small reward or no reward at all. And AWS provides us with few example reward functions to, again, help you with your journey, to help you start with that service. Here we see the example function provided by AWS, and what it is about is telling the model to stay relatively close to the center of the track, and that's it. As you see, we have if-else instructions. So if it's closer to the center, it receives the 1.0 because it's a float number. Yeah, what's important, I forgot to mention that. Think about reward like points, and the point is float number. So yeah, here the highest possible in this particular function in this step will be 1.0. If it's like not close to the center, but it's not off of the track, it will receive 0.5 and 0.1 if it's close to the end of the track. But you have other examples also. If you click here, you can see the time trail stay inside two borders. So stay on the track, exactly. Prevent zigzag, because models sometimes can just learn to be close to the center of the track, but drive only zigzags, and it will have also a bad outcome on the time of lap. In reward function, you have a params dictionary. It's in Python, it means dictionary. It's a pack of all the parameters, all the informations about your model, about your car at this given state. And what's in here, you can see it if you click on Learn More. You have described all the input parameters. Click on Learn More again. And here it is. It is also covered in the Get Started page, by the way. Here it is, list of all possible parameters. So it's Boolean, true or false, all wheels on the track, yes or no. Object distance from the center, as on the example function, is crashed, true or false. Speed, which is important because maybe you want to reward your model based on the speed. And steps, steering angle, all of the parameters you can use in your code to consider what reward the model should receive. But I don't want to dig into too much details. We'll create the model with default parameters. We'll have to wait 5 minutes to initialize the training. Okay. And in the meantime, we can talk.
Okay, so what we are doing now, we will be just creating by default our second model, and we'll wait until it will be created.
Yeah. So two another things, hyperparameters. Please learn about it in the Get Starting page, but I don't want to, and again, dig into too much details to not overwhelm you with the amount of information for now, and we don't have enough time. The important, however, parameter is stop condition, which means for how long we want our model to be trained. Usually I put there something between 2 and 3 hours. You can still train your model again after the first training, but after 2 hours you should be able to see if your reward function is going well in the good direction or not. So I will put here 60 minutes because I will not use that model anyway. I don't want to submit my model into any race for now, and I'm creating on create model. And that's it. Our training is being initialized. After 5-6 minutes, we'll see the live video stream from a simulator. So we'll see how our model is training, how it drives on the beginning. Later, I will show you how it drives the fully trained model, based on an example from real community race. And I will also show you the example of real DeepRacer.
Okay, so we can consider the job is already done. Yeah, so there are 25 lines of a very simple code. The variables are pretty much well explained. You can play with all of them or with some of them. You can use it all or some.
Yeah, that's it. I already won the $200 in our community race.
Exactly. So why it all serves? So within a few minutes, you are capable to play with machine learning and to have fun with autonomous car on a virtual lane. And this is how you should start the business of presenting that to your clients if you think about making some projects with use of machine learning. Start on machine learning adoption as fast as it gets and make this AI explainable. This is how AWS platform is working. So it is well explained and it works pretty fast. And machine learning developers and product managers, they need to understand that there are many potential customer barriers. And of course, the best practices already are how an individual will interact with the system, what's the transparency of the system. But for the mystic artificial intelligence, it is even more important to have it well explained. So we need to give early access, as AWS platform is doing, to the beta programs, to something which occurs on with the projects, so that the clients, they can give us a feedback on workflow, on outcomes, and actually we need to think about how it will be understood, and we need to gain trust of our customers at the early stage of the projects. So we need to ensure that the software-driven actions are predictable and the recommendations are transparent, they appear in the right place in the application. This is something what we are doing. And that will be exactly with AWS. So if you have any issues, contact Simon, who will help you to also to set your car properly.
Yeah.
And because what happens, 48% of the companies, of the people that they are using machine learning in practice, they respond, they acknowledge the difficulty of versioning of machine learning models and reproducibility. So the lesson here is that the new obstacle emerge once machine learning models are deployed to production and used in the business process. So what we need to do, we need to monitor the production of machine learning models for drift. We need alerting when the drift is significant. We need to recognize when the models require upgrades. So as an organization, we need to combine two: model management and the operation. So the people, the companies using machine learning already, they call it MLOps. So it's a union between software developer practices and the scientific methods. So as a software developer, you know probably that deploying an app isn't trivial, and it is even a greater challenge when it reaches the production. The end users, what they expect: regular enhancements, maintaining of the underlying infrastructure, the libraries that require patching and maintenance. So we need to provide that. On the other hand, we need to apply for the scientific methods. So each questions lead us to multiple hypotheses. So we need to experiment all of them to maintain logs of all that ways of experimentation. We need to go through all of them. We need to track the journey of tweaking different variation from one experiment to next. Not only just to be sure that everything will be well done, but also it leads to it will be easier to convince our peers, our teammates, than that we've explored all the variables and the models are reproducible. So be aware that your customers, they need to be aware what we are doing on the early stage. You need to maintain logs, and you also need to be alerted on drift in the actions. But you will see that also here on the DeepRacer platform, that sometimes it occurs that even the longer training goes.
That all depends on the hyperparameters, because when you incorrectly set some of the parameters, that the gap between let's say steps of the training can be too high, and you can miss the golden point of your DeepRacer, the golden point where your DeepRacer is performing the best. And you can, because the step will be too high, you can just skip it, and the end solution, the end model, will not behave as you want. Will not behave the best, actually. Yeah, but the training should be ready. So I'll refresh the page, and what we see is on the left side reward graph. I will show you an example of full graph later on. But here we have the live video, as I said, live video stream from the AWS simulator, where you can find your own model already driving, and we are able to see how it performs on the track.
Wow, it performs well already on the beginning.
Yeah, let's say it performs well. I couldn't drive like that on the real roads, on the real tracks. But after 2 hours of training, I think this particular model will be not too fast. It will be actually pretty slow, but at least it will stay close to the center of the track. It shouldn't drive off of the track, because that's what our reward function is rewarding. Actually, stay close to the center of the track.
So what we see right now is just a fresh configured car attempting to finish this simple lane.
Yes, it's already 4.5 minutes of this training, so it's not much. It's still the early stage of the training. That's why the model is not like super fast. It's not Robert Kubica yet. But now I will jump to another model with the same reward function, just to give you an overview how looks the reward graph. So as you see, the green color means the average reward on each iteration of the training. So as we see, the reward function is actually, the chart looks pretty nice, because also the percentage completion of the track, what means how many track in percent the model completes in this particular iteration. It works also pretty nice. It didn't complete the full track, but it was pretty close to do so, because it was 87% on the training, and yeah, actually, it completed the track. I'm sorry, it completed in 3 iterations, as you see in the evaluation. So it's good. It's good. And what's the difference between training and evaluation? In training, model is like pushed to take random decisions, and in evaluation, it just shows us how it completes, how it behaves, based on its experience. So again, in training, there are random actions just to stimulate the model to explore the environment. Look, I know that you already are doing pretty well because you complete 80% of the track and the reward is higher. But maybe if you now take the left turn, there will be higher reward waiting for you. So this is the stimulation of inserting random actions to the training, just to stimulate the model to learn.
Okay, so our model is now exploring the new possibilities to get the higher reward, but we can also make from this very simplistic car a Ferrari.
Yes, we can, but in a few seconds, because I want also to show how behaves the fully trained model in a simulator. Here we have the old AWS DeepRacer Beginner Challenge. It was a community race organized by AWS in May of this year, and there was huge promotion of that event. So basically, the model, as you see, my rank is 77, so I'm not the best driver, but let's take a look at the model who made this track, this particular one, in 8 seconds, just for comparison. My model made the lap in 18 seconds. So let's see how 8 seconds looks like. You see, pretty fast. Much better than our Robert Kubica in a simulator. Yeah, but another thing is that the DeepRacers, the competitions in DeepRacer also happen in real world. We have real cars competing on the track. And here you see the example of the championship cup, as how the real car were performing on the track. Because moving a model from a simulator to real world is not very easy. Yeah, actually, I just wanted that few seconds of car on the track. It's not very easy. Model can behave slightly different because the image captured from the camera can contain some noises. The light can be bad or something like that, but still, it should perform pretty similar to what we achieved in this.
Okay, but right now we will be not using digital signal processing, no lidars, just virtual cars.
Yes.
Okay, so let's go back to the garage, because we need to pimp our rides.
Yes,
let's
exactly.
see, because we can do also better with
Pimp my ride.
With them.
Pimp my ride. Yeah. Now I would like to show you how you can modify the default car and how you can modify the maximum speed, for instance. And how can you submit your model? Actually, yeah, how can you submit your model to the community race? So back to the garage. Where is garage? Garage is here on the left side on the menu. Click on that, and here you have build new vehicle. And what you can select is if you want a single camera or stereo camera, so two cameras in front. We'll stick to the single camera. You can also have a LiDAR sensor, but it's necessary.
Which is actually not the case in this race.
No, in this race it's not, but you can have it for head-to-head racing or more object avoidance. But we are sticking to the old school, and we will just create model with single camera. And what you can do, you can modify the maximum steering angle by the value should be between 1 and 30. I will leave the 30 degrees as it is. You can change the steering angle and granularity, so the model will have 3 possible choices of turning, go straight, left, or right. You can change that to 7. It will be more granular, as the name is saying. I will select 3, for example. And the maximum speed is 4 meters per second. I will check this. I will select that. Why not? Let's make a Ferrari. And we have the same as with the steering angle. We have speed granularity. I will select 3. And here we have the action list. It's just an overview for you to see which actions a model can take and what will be the parameters actually of the steering, of the speed. Yeah, so that's it. Click on next. Supply your new car with a name. How we will name it? Sorin's Ferrari. Sorin Ferrari. Unfortunately, I have already that car, so again, place 2. Sorin Ferrari 2. I will have 2 of them. Why not? And the color of Ferrari, of course, needs to be red. So I am selecting the red color. It doesn't mean anything. And you can create your new model with. I will just put test 1, 2, 3, not selecting the environment, and you can select the Sorin Ferrari 2 from the agent list. Yeah, so this is how you can train a model with custom car. Please remember that after first training, you are able to change the track of your model to train it during second training on another track, but you are not able to change the car. The car stays with the model. So if you want to modify parameters of the car, do it first and then create a model. That's very important.
Okay. First configure, then create the model.
Yes. As I said, you can execute multiple trainings, and to execute second training of your model, go to your models. For instance, this one, and you have here on the action list clone button. Click on that clone button, and you can create another model, but it already has the experience from the previous training, so you can improve it. Not train from the scratch, but you can improve it. You can change the track if you want. Why not? But you can't change the agent. You can't change the car. Okay.
All right. Anyway, we are here for you, guys and racers, for everyone who would like to try with us and configure its own car. As you could see on that example, Simon did it within a few minutes. So he configured the car and he came back to the garage and then changed and modified the car, and it's now learning with use of RL to perform on the lane. Why we are all doing that? So we are doing that because the machine learning can also predict market behavior already. So this is another press release that I saw last month. Cornell University researchers, they released a paper, and they assessed the effectiveness of that mathematical tools so high that that it predicts already the movements on financial markets. So imagine the vast amounts of data that goes through their models. And so at the times in which we deal with the massive amounts of data and high volatility of the data, machine learning should apply actually everywhere on the market. And we strongly encourage you to try with us with the AWS and Sorin Lab DeepRacer. And we also encourage you to think about your applications and your business models, how they can improve with use of machine learning. This is all about. So we have 5 minutes to go.
Yeah, can we again put the screen of my laptop with the Sorin Lab contest? Okay, thank you. Just a few words about our race. This is our community race created by me for you. And this is the race where you can submit your model after this presentation. We will provide you with the invitation links to this model, to this race, via email tomorrow, I believe. So
if you don't get an email, if you would like to participate in the race, please contact us via email. It will be shown.
Yeah, I will show on the end slide. But yeah, here is the race. You can submit your own model. And the conditions are like that. You have 7 days starting from today. So you have 7 days to train to submit your model. Your model has to complete 1 lap to enter the race. So this is like condition. It has to complete 1 lap. And we will simply take the single lap time. The fastest lap is the one which will be considered, and you will see your model here on the leaderboard. As I said on the beginning of this presentation, the fastest free DeepRacer models will receive from us credit codes for AWS platform, $200 each.
Okay, so this is the return on investment, but what is the investment? Because there is some cost behind that, I know that already. Very little.
Yeah, very little. As I said on the beginning, you have to have your own AWS account. Unfortunately, we can't provide you with prepaid AWS accounts, so you have to use your own private account. DeepRacer is not free service. The cost of DeepRacer, it's also mentioned on the when you create a model somewhere on the bottom. Okay, I don't want to waste time here, sorry for that, but there will be the information. The price for DeepRacer is $3.50 per each hour of training.
And you need something about 2.5, maybe 3 hours of training. So your
depends how good models will be in our race.
So your investment around $10 and your potential return on investment $200. So please join us and win the prize.
You put $10, you take back $200. It's better investment than in Bitcoin, in my opinion.
So it's better than drugs. So you can always contact us, and you can also learn with us how to play with that. Here you see our emails, so you can contact us directly, or just wait for our follow-up tomorrow if you give your email address by login.
If you're interested in DeepRacer in particular and nothing else, I highly encourage you to join the DeepRacer global community, which is very big. It's actually named the Amazon Machine Learning Community. There is a lot of people who want to help you. There are the finalists from Las Vegas of DeepRacer, the best DeepRacers from the whole world, just waiting for you on that particular Slack channel. So feel free to put the URL in your web browser. It's join.deepracing.io. Join the Slack workspace, and the community is waiting for you and your questions if you have any problems with DeepRacer.
So have fun. Thank you very much for this session. Cheers. And we are waiting you on the platform.
Yeah, we'll be waiting for you in the one-to-one Q&A channel.
Okay. See you then.
See you. Bye.